Hello everyone, this is Dr. Kalpana and you're watching my YouTube channel Pharmacy Lessons Made Easy. The topic for today's video is evaporation. Let's begin. First, we should understand about this unit operation. What is the definition by which we can elaborate it? Actually, it is a process in which large quantity of volatile liquid is vaporized so as to get the concentrated product, right? The practical definition for this is removal of solvent from solution by boiling the liquor in a suitable vessel and withdrawing the vapor, making a concentrated product at the end of the process, right? So for this evaporation to be carried out, we use the equipments, and those equipments are known as evaporators. Actually, as a general process, we supply heat to the evaporator, that is this equipment. This transmit the heat to the evaporating liquid which is to be evaporated, right? And that liquid will receive the latent heat of vaporization. For providing this heat, the most commonly used source of heat is steam, right? Actually, the evaporation is a surface phenomena. That means the mass transfer which actually is happening from the surface, and no boiling is involved, as the evaporation is a surface phenomena and it is a slow process, right? So the next question that may arise in your mind is, what can be subjected to evaporation? The answer is either the solutions or suspensions. Both can be subjected to evaporation. The condition is the liquid must be volatile while the solute must be non-volatile, right? So when we supply heat, the constituents should be thermostable, otherwise they will lose their integrity and may degrade. This may lead to toxic products also, right? So for that cause, we should use the constituents which are thermostable. Most operations, the liquid involved is water, and comparatively lower solid content liquid is used. The liquid which is to be evaporated may be less viscous than the water, or it may be so viscous that it will hardly flow. So once this evaporation process is ended, at the end we shall get a concentrated product, and it will reach to such an extent that further evaporation will drastically reduced. Sometimes we may get confused about the evaporation process and other processes which involves heat process, like drying, distillation and crystallization. These processes also include or involve heat during their unit operations. So how you differentiate between other heat processes and evaporation? Here is a table. See, in drying process, the residue that we get as the end product is a solid, whereas if we compare evaporation with it, the residue is a concentrated liquid in case of evaporation. Similarly, in case of distillation, evaporating liquid is a combination of two or more components based on the difference in their volatility or boiling point, whereas evaporating liquid is only one component in most of the cases in case of evaporation. Moreover, we do not attempt the separation of mixture of vapors in the case of evaporation, while compulsorily we are separating every component of the mixture in case of distillation. Now if we talk about crystallization, the purpose of concentrating the solution is to get the crystals as the final product, while the purpose of evaporation is to get a concentrated liquid only, but not to get crystals, as it happens in some situations, right? So where we shall apply this evaporation process? It is used in the manufacturing of bulk drugs. I mean the actual pharmaceutical ingredient like paracetamol as such or other bulk drugs, and it has been used in pharmacy practice, pharmaceutical industries, and as well as chemical industries, right? Moreover, the biological products, if we wish to manufacture, in that evaporation plays a very important role, such as insulin, biochemical products, plant products, all these involving blood products such as plasma, blood serum, all the processes involves evaporation as unit operation. But in these cases we should not directly heat the liquid, right? Because it may cause the damage or degradation of the biological products. Generally we use freeze drying for this purpose. Water that contain minerals is also subjected to evaporation so as to get demineralized water after condensation, and such water can be utilized for consumption by human beings or may find its special processes. This is some sort of evaporation through the process, is generally called distillation, right? So that way evaporation finds its application. Okay, now moving to the next part, that is what are the factors which affect the rate of evaporation. I mean, how the evaporation will take place with respect to time. Okay, the first factor that affect the rate of evaporation is temperature. It is generally observed that higher the temperature, the greater will be the rate of evaporation. Why this happens? Because at a given temperature, the molecules present inside the liquid possess the kinetic energy, and that kinetic energy is higher than the average than other molecules at the surface one. Okay, the fast moving molecule will escape from the surface of the liquid into the vapor form, whereas the particles which are slowly moving will remain behind. When temperature of the liquid is raised further, what will happen? More and more molecules will acquire the kinetic energy which is sufficient for them to escape from the surface to the vapor state. So this we are talking about the situation where the boiling point of the liquid is not yet achieved. Okay, below this boiling point the vapor is formed only from the surface. At boiling point what happens? Being a bulk phenomena, vapors are formed throughout the body of the liquid as well as from the surface. So the vapor pressure of liquid is lowered when the substance is dissolved in it, and as a result the boiling point of liquid increases. Okay, so if we talk about temperature, then we cannot increase the temperature of such substances which are heat sensitive, like hormones, enzymes, antibiotics, and some of the herbal products like glycosides, alkaloids. So for them we require special techniques so as to prevent their decomposition during evaporation. Okay, so for these, like preparation of antibiotics, also you need a special process called freeze drying or lyophilization. Okay, so that was like how temperature is affecting rate of evaporation. If we move to the second factor, that is vapor pressure. Actually more the vapor pressure of the liquid, more will be the rate of evaporation. That means the relation is in direct proportion. Okay, if the external pressure is lower, then boiling point obviously will be lower, and hence more will be the rate of evaporation. How can we achieve such lower external pressure? This can be achieved by applying vacuum. Okay, now vapor pressure will be different for different types of liquids. So the nature of the liquid, whatever you are subjecting for evaporation, will matter a lot. Okay, how? The liquid which are having lower boiling point, that means they can easily and quickly evaporate, because at the same temperature comparatively higher vapor pressure will be exerted by a low boiling point liquid, right? And if we talk about the outer atmosphere, second condition is when it is dry, right? If the vapor of liquid is removed as soon as they are formed, that means the space which is above the liquid will not become saturated with the vapor, so faster evaporation can be taken place. The next factor that affect the rate of evaporation is surface area. Okay, so if we take greater surface area for the evaporator in which the liquid is to be subjected for evaporation, the more will be the rate of evaporation. For this reason, generally large heating surface area evaporator is used for evaporation at higher scale. Next factor is moisture content of the feed. That means some drug which may get affected by the moisture content, we should have to take care, or you can say specially take care for them. Like some of the drug may undergo hydrolysis and may get decomposed in the presence of moisture at higher temperatures. To overcome such decomposition, the material is subjected to lower temperature at initial stage and then at higher temperature for their final concentration. As an example, if we talk about belladonna, its dry extract is prepared that way. Okay, that means initially lower temperature and then for final concentration move it for higher or subjected to higher temperature, right? So what we have understood about temperature, how it is going to affect the rate of evaporation, then vapor pressure, then surface area and moisture content of the feed. Let's move to the next factor, that is type of product required. That means what exactly is the type of product that you require. It is a deciding factor for apparatus of evaporation also. If we take an open pan, it will produce liquid or very dry concentrate. Okay, comparatively if we take film evaporator, that may lead to liquid concentrate. If we take spray dryer, it will produce a very high solubility dry product. Okay, if we use vacuum evaporator, it may result in porous product. Okay, so with this porous product, what is the advantage associated? We can convert it into granules. For example, if we wish to prepare cascara extract, then if we wish to convert it into final tablet form, then the granular extract can be prepared using evaporation. The next factor is the time of evaporation. That means how much we are exposing it for evaporation process. Okay, if we are taking more time of exposure, then rate of evaporation will obviously get increased, provided we are not using a thermolabile product. Okay, so exposure of drug to higher temperature for a short span of time can be less destructive, okay, than lower temperature with higher exposure period. Okay, that is why we use film evaporators, okay, rather than pan evaporators. Next thing, if we talk about the hurdles, then they are films and deposits. They also affect the rate of evaporation, right? So what is this deposits and film? Whenever we subject the vegetable extract, right, in a steam pan or a pan evaporator, a film will be formed on the surface, or some matter may get precipitated out and get deposited on the heating surface. So this film, what it exactly do is, it reduces the surface of evaporation, okay, from where the evaporation has actually to be taken place. and precipitated matter will hinder the heat transfer rate. Okay, in order to avoid such problems of films and deposits, stirring is very important, and it should be efficiently and continuously done. Okay, so that the evaporation rate should not be adversely affected. Next factor is economy factors. That means actually this is a prime consideration for any pharmaceutical industry, because ultimately economy related to the labor, fuel, materials, raw materials, floor space, packaging material, all has to be taken into consideration. The recovery of solvent, that is also important, whether it is environment friendly or not, utilization of waste heat, they all are also important and involve considerable reduction of cost, right? So if we summarize all the factors by a journal equation, the rate of rate of evaporation will depend on several factors. Relationship can be expressed in terms of a mathematical equation as m is equal to Ks upon P multiplied by V minus B prime. That means here capital M is representing the vapor mass which is formed per unit time. Okay, that means the rate of evaporation. K is a constant whose unit would be meter per second. Capital S is the surface area of liquid exposed in meter square. Small p, okay, in the denominator is representing the atmospheric pressure in kilopascal. Small b is maximum vapor pressure at the temperature of air in terms of kilopascal, whereas if the same vapor are present in the air at actual condition, okay, that pressure will be represented by B prime. Again its units are kilopascal, right? So this is the general equation which is representing all the factors involved. In the next video, the classification of evaporators will be covered. I hope you people enjoyed this video and understood the topic well. Do click on the like button. If you like this video, subscribe my channel for frequent updates and share it on social media. Thank you.